It's amazing that something as complex as the human body is made of only a few elements, and 95% of our weight comes from only these 4 elements. What do these 4 have in common? Oxygen, carbon, hydrogen, and nitrogen. They are all nonmetals. So how do we get from this to this? By covalent bonds. This is going to be all about sharing and forming bonds. That's right, it's all about nonmetal atoms. Nonmetal atoms share their electrons to form covalent bonds in a process that benefits them both. When 2 atoms share a pair of electrons, they get joined together. Depending on the atoms, this bond can use 1 pair of electrons or several pairs. The electrons that are shared are always in the highest occupied energy level of the atom, the valence shell. The sharing gives both atoms a complete highest energy level. You know this as a stable octet. The covalent bond that is formed is very strong. It takes a lot of energy to break it. Take hydrogen and chlorine, for example. If you know your atoms, then you know that hydrogen has 1 electron in its highest energy level and chlorine has 7. Give the hydrogen a nudge. When these 2 form a covalent bond, this adds 1 electron to the hydrogen's highest energy level and 1 to chlorine's highest energy level, completing both of them. Remember, 2 electrons fills the first energy level and 8 fills levels 2 and 3. The combined molecule is called hydrogen chloride. The N of chlorine becomes a D in chloride, just to trip you up when you're doing your exam. Covalent bonding between 2 atoms needn't be with just 1 pair of electrons. You can get 2 or even 3 pairs, but always pairs. It's like socks, shoes, gloves, or eyeballs. Here's a way to work out how many covalent bonds an atom can make. It's 8 minus, wait for it, the valence electron number. What's the valence electron number? Remember your periodic table? You wrote the valence electron number at the top. In fact, for now, we're going to ignore the middle section of the table and just call these red valence electron numbers the group number. Covalent bonds form between nonmetals, so let's zoom in on that side. In this magazine, the noble gases have a 0 because they don't form bonds. If an atom is in group 7, then it's going to need 8 minus 7 equals 1 covalent bond. It's only got 1 gap in its highest energy level. Yeah, you get the idea. 8 minus 4 is 4. 4 bonds. 8 minus 5, 3 bonds. 8 minus 6, 2 bonds. All right! The number of bonds an atom will make is the same as the number of electrons it needs to reach a stable octet. There are 2 standard ways to draw these bonds. I like covalent bonds so much I often draw them both. The most common is to join the chemical symbols with a straight line. Like this. Want to see the others? If there is more than 1 shared pair of electrons, then you need to join the atoms with more lines. A double bond uses 2 lines, and a triple uses 3. Another way to show covalent bonds is a dot and cross diagram. Here is a chlorine atom, but when you draw a bonding diagram, you only need to show the electrons in the highest energy level. They are the only ones which can bond. Here's how you show a chlorine molecule. 1 pair of electrons is shared between the 2 atoms. It's a magical moment. Chlorine gas is made from molecules like this. And here's how you'd show oxygen gas. Notice that these atoms share 2 pairs of electrons. This is a double bond. Now let's mix it up a bit. Here are some compounds. That's when atoms of different elements join together. Isn't that hydrogen chloride as a dot and cross diagram? And here are the ingredients for water. Let's see them bond. Notice that both hydrogen atoms now have 2 electrons in their highest energy levels, and the oxygen atom has 8. Okay, whatever you can smell, that's not me, that's ammonia. It's made from 1 nitrogen atom with 3 hydrogen atoms. And it stinks. There are 3 covalent bonds here. Carbon can make 4 covalent bonds. When it does this with 4 hydrogen atoms, you get, you've guessed it, methane. Methane is represented like this. The carbon in the middle needs 4 bonds, but each hydrogen only needs 1. That was pretty exciting. Not the rocket thing, obviously, just the fact that methane is formed with 4 bonds.